I want to start off by saying good afternoon. I see that the activity has failed. Let's retry it again. Good afternoon. One last time. Third attempt. Good afternoon. Thank you so much. So let me just grab my pointy thingy. So today we'll talk about scaling platforms engineering with Temporal at Nutanix. First thing is, let's get legal out of the way. Just some note around forward-looking statements, product or roadmap information, as well as third-party reports, as well as publications. So with that, my name is Bharadwaj. Again, you get $100 of Temporal credits if you can say my name properly. I'm an engineer manager at Nutanix. Again, the description is whatever, it's fine. So let's get to the crux of it. What is Nutanix, right? So the company started somewhere in 2009. Essentially, before this, you had something called a three-tier architecture that companies used. So essentially what that means is you have a computing layer, a storage layer, as well as a networking layer, right? And all of this is very cumbersome to maintain on your own. And if you wanted to scale, you had to scale each of these individually, and maintaining it is very complex. So that's where Nutanix came in, and we pioneered something called hyper-converged infrastructure. That means you just buy a server, commodity server. It already has the disk for you. It has compute, and you hook it up to your top-of-the-rack switch. And if you add more of these nodes together, they form a cluster, right? So we've come a long way from that, and now we're doing something by revolutionizing, and this is where we're building a hybrid multi-cloud. So essentially what that means is from a single plane, you're able to operate your application workloads across your private clouds as well as your public clouds and bring the whole experience and make it seamless, right? So what does that actually include? Meaning your choice of hardware. Right now we have many options with respect to vendors. You can just get commodity hardware, and you have hypervisors. Again, we have Nutanix AHV, Acropolis. We have VMware vSphere as well as Microsoft Hyper-V. So apart from that, if you're not on-prem, you can still be on cloud. So with this, you can do stuff like adopt like AWS or Azure or GCP. And if you're on Kubernetes, the best thing is you can manage Nutanix Kubernetes clusters using GCP's Anthos or Arc-enabled Azure Kubernetes clusters, right? So we're there all across the board, and we're making sure that your apps basically exist across all clouds, and we're making cloud invisible. Here's just a snapshot of what all we offer. If you look towards the bottom, you see that there are cloud infrastructure. Essentially, you can have VMs or containers, be it private or public. Basically, your apps can extend between both of these seamlessly. We have tooling for that. Somewhere in the middle, you have everything that applications need. Basically, a file store, an object store, as well as a block store. We provide all of that out of the box. And we provide database services as well as services for Kubernetes, especially your data services, to ensure that they can be maybe backed up as well as replicated to another DR site at real time, right? And finally, at the top layer, we have a unified control plane. Essentially, you have federated management where you can provide access to different users, to scope down to different projects for different resources. And you can do a lot more things, like you can get insights into your security, you can do automations, you can get AI-assisted reports, as well as data governance. So with all that out of the way, you're free to run your application at the top, right? You have all of these things that we provide. So in all of this, if you see, we have primarily three business use cases. One is we host SaaS applications, SaaS offerings. The second is we build products which we can ship to customers to install on their on-premise. And the final one is because of our partnership with various cloud providers, this also becomes a product that you can run. So when you think about this from an organizational perspective, right, there are engineering teams. And just looking at engineering teams, you see that there are these cross-cutting concerns that all of them deal with. The first thing is, should they be really worried about all this is our question. So if you look at it, an engineering team has to manage, provision, and maintain the infrastructure. So this has to mean that before you even deploy your apps, you need infra, and you need to, on a day-to basis, like when your application is deployed, you have to make sure that it is patched, there are no vulnerabilities, and you have to be compliant, right? Another thing that they have to do is, even when they design apps, they have to think about how it has to be highly scalable as well as highly available. So for this, they really have to think and architect of how this has to flow, right? Apart from that, they obviously need a build and deploy pipeline because you want your engineering teams to be agile and you want them to innovate fast and iterate, right? And apart from that, you have to provide some sort of way for them to have synchronous as well as asynchronous communication. Synchronous, of course, we all have achieved this using APIs, but sometimes that is not always what is meant, meaning there are these tasks that require like a lot more indefinite time, right? So that's where you have to think about asynchronous communication. Another thing is, because when your apps are deployed, now your day two operations start. You have to look at telemetry, right? So you have to capture your logs, traces, as well as metrics, and you have to make sure that developers have availability for all this. They're able to get in and look at things. And that is where access management comes in. You have to provide a way for them to do it securely, but you have to provide a limited scope to it, right? And all this has to be audited. So again, when your app is deployed, it's very common that we get on-call as well as incidents that happen. So we need to provide a way for developers or engineering teams to do this quickly and safely. With all of this, when your application is finally there, customers will ask you, why should I buy your app? Show me all of your accreditations. So this is where you have to make sure the platform, as well as the teams running on top of us, they're compliant with respect to certifications like ISO, SOX, as well as FedRAMP, right? So here is what a typical operating model looks like. So essentially, we don't want engineering teams to look at infrastructure, right? We want that to be completely abstracted away. We need to provide services to them in order to consume, right? So for us, the only thing that we require is nothing but an infrastructure provider and hopefully a container orchestrator, something like Kubernetes. Your infrastructure provider can be anything, maybe on-prem, maybe Kubernetes, could be AWS, could be Azure, could be GCP, it's fine. And this is where we are on top, right? So a typical platform team, we provide all of these services in little blue boxes that you can see, like a service mesh, deploy pipeline, some observability stack, a workflow engine, which we all know what it is right now, pub subs, queuings, cachings, RDBMS, as well as analytics stores, right? So on top of this is where developers sit, or engineering teams. They consume us via a self-service portal that we'll get into shortly. And hopefully they have some sort of secured SDL so that we're not compromised in any way. And overseeing all of this is an InfoSec compliance team. Essentially, this goes through the whole stack, from vulnerabilities from your infrastructure to the packages that you use are mostly flagged by them. And this is a repetitive loop. So with that out of the way, let's talk about some of the tools that help us achieve these things, right? So when we have to manage workloads, we need to design a platform that is capable of it. And when you look at this, you know that you can do much more things than a hammer, right? Because for us, not every engineering problem is a nail which we beat with a hammer. So this is why we chose Temporal, right? Why is what I want to talk about. So first thing is, obviously, code-first approach, right? I don't want to have another DSL, or I don't want to maintain some files that have to manually change. Rather, I would like to have it co-located with my functions, right? So the best thing is, once you integrate with code, you don't have to worry about a lot of things. Temporal takes care of the rest. Another thing that we're looking for is durability and retriability, right? I want a platform that even though if my worker, in our case, Temporal worker, or server itself dies, I want the state to be persisted. And I want my actions to be retried if they fail with some options that are set. Another thing that we really want is scalability. So when you look at SaaS, it can get incredibly complex, right? So, but fortunately, Temporal has these 4 components which can be scaled horizontally as well as vertically, and you can fine-tune them according to your use case. Again, like I mentioned earlier, we are a polyglot system. We employ microservices like crazy. We have like 200 plus microservices. So Temporal just fits in there because we use max like 3-4 languages, and Temporal has an SDK for all of it. So the fit is just, it's seamless. Another thing that we really like about Temporal is observability. So before, again, show of hands for those who have used some queues before Temporal. Can you show maybe your hands? Okay, so tell me this. Did you ever think that you could have centralized visibility into your workloads? I probably think not, right? With Temporal, there are APIs that help me decide what actions to take based on the state of my given workflow, state of executions of all workflows in my namespace, and I can even tag them with attributes in order to query them, right? So this out-of-the-box observability is really mind-blowing. Apart from this, because we're a platforms team, every other team consuming us needs to have their own namespace. So Temporal provides this out of the box, and it supports multi-tenancy. So right now, we just give everybody a set of namespaces that they own, they have credentials to, and they're rate limited, right? And apart from this, Temporal is surprisingly very extensible. We will get to it more in the end, but this is one of the hard-hitting features that actually helped us choose Temporal as a viable solution. But Temporal is not obviously everything. We have the other heroes or the other Avengers. Again, show of hands, how many have you run Kubernetes? Wow, okay, nice. So as we all know, Kubernetes is a container orchestration, container workload orchestration. Essentially, if your app is containerized, Kubernetes can ensure that you're able to scale it, make it discoverable with other services, as well as run its whole life cycle. Another one, ArgoCD. Anybody running ArgoCD? Okay, wow, okay. The right side is winning, guys, I'm sorry. So ArgoCD is this very nice tool, which is open source. Essentially, what you can do is, if you're managing maybe your workloads, this could be any Kubernetes resource, you could version them in the GitOps repo, and that serves as the state of truth, right? So whatever is there will be deployed onto Kubernetes clusters. And even if there is a divergence or a drift, ArgoCD makes sure that it is reconciled properly and you go back to whatever is required. And this I'm pretty sure no one is using. Anybody using Clutch? Okay, great, that's why I'm here, okay. So Clutch is maybe an alternative you can think about for like Backstage, right? So it is basically a self-service developer tool introduced by the folks at Lyft, competitors to Uber. This came out way back in the day, but yeah, we're using it. So anyway, let's get back to a typical architecture. So imagine there is a team that wants to deploy the latest models, AI models, and test them across different clouds, right? So we would have a bunch of Kubernetes clusters sitting across different clouds, including our own. Obviously, developers never talk to infrastructure directly. That is why we have Clutch in between. So they can interact with it via a UI or an SDK, right? And all of the state of Clutch is stored in a Postgres database. So basically, when an engineering team comes in, they're trying to spin up a new service, maybe to download the latest model and run some tests to check out how it performs. So when they do it, basically they click a few buttons and we generate the resources using Clutch into GitHub. And ArgoCD basically picks it up from there. And accordingly, it applies this to whatever the destination Kubernetes cluster is. And this is like a continuous loop, right? It's not like once you do it and you forget about it. As you make changes, they'll automatically be synced into these different clusters. And for everything else that is asynchronous, Temporal really fits the bill. So let's talk about some use cases where we're using Temporal heavily. So we will go through some scenarios, some struggles, pain points, and finally some viable solutions, right? So, okay. Again, how many of you have employed microservices in your organization? Show of hands, maybe? Okay, that's pretty good. So essentially, the scenario is this. When you have a typical transaction, right, you're trying to maybe, once a customer signs up, you're trying to go to the payment gateway, you're trying to send emails, you're trying to do all of these things, but the data is scattered across different services, right? And obviously, the pain point is that data is actually scattered across different services. Your API calls to get that data has no guarantee of passing, right? And you don't know how retry even looks like, and you don't know what the intended cause is. So this is where we leverage query handlers and signals. Let me just show you what that looks like. So this is more or less a bare-bone workflow. You have maybe 2 activities. But now the thing is you have 2 services, maybe A and B, that either want to take some decisions or maybe update a few things, right? So what we can very nicely do is with Temporal, you can actually register a state using variables, structs, and all of that. You can register them to query handlers. You can have many query handlers per workflow. Each query handler can give you a different view of what the current state is. And of course, you can register signals. So now, A and B can take independently decisions where they can either query your workflow for a single state or multiple states, or update your workflow, right? So the best part about this is it is real time and I don't need another data store. Like Temporal becomes my single source of truth, right? So that's very good. Another thing that we use it for is automated CI/CD pipelines. Essentially, again, like I said, we run hundreds of microservices and we run this across many developer environments. Code is constantly being pushed out and it is being merged to main. Of course, when something is merged to main, you have to make sure that it is rebased and back merged into all of your dev, QA, and test branches, right? But the pain point is that if developer teams spend most of their time, they're not building features and your company is probably not accelerating to where it wants to be, right? And of course, the code drifts causes inconsistency in state where the whole testing process goes for a toss. So to solve this, we actually started employing child workflows. So what that means is if there is maybe a PR raised from your version control, the hook is basically sent to a pipeline service that we built. where we trigger a single workflow. Based on how many branches the service has, this temporal workflow will spin up a child workflow that spins up a pull request for each of those branches, and it makes sure it's automatically merged. And once it's merged, it kicks off a CI pipeline. Basically, it runs all your unit test cases as well as your integration test cases. And if everything is good, basically the build is ready, right? In a way, it is promoted. So we update that state in Clutch. And as I mentioned before, Clutch is our central source of truth, pushes that to GitHub, and ArgoCD picks it up, applies it on the desired cluster, and we send out notification to the respective team. So in this way, at least, we only see about 5 to 10% of the time where a pull request cannot be automatically merged. That is where, obviously, when developers or engineering teams have to get in. But otherwise, do you see like how it is so easy and it is very straightforward to actually make sure that the code is consistent across all these environments? Okay. So another thing is, real-time alerting. As I mentioned before, in order to have a nice debugging as well as on-call related infrastructure, we need to provide the same to developers, right? So we have logs, traces, metrics, and even in them, we have subcategories because we employ different open source tools. So because you have all these, you need to provide monitoring capabilities, and they need to respond to events, right? But again, it's too cumbersome. How do you send alerts such that developers don't think it's noise? Can we do something about it? Is there any centralized way of doing about it, right? So again, this is what we did. Essentially, for every alert source that we have maybe notification streams as well. You basically spin up one workflow that is long running per data source type, and you basically signal these workflows with the alert. And this is where you add some metadata. And all of this, after enriching, is piped to Clutch. Because Clutch knows which service belongs to which team and their preferred means of communication, it just routes it based on whatever rules we set. So in this way, we are able to get actually consistent performance and real-time events as well. Okay. Again, centralized approvals. So if you're ever running a product that has certifications, you know that auditors will grill you for every time you make like a workload change, right? When you try to push out a new feature to production, there's always this thing like how many people have actually approved it, who has done it, and what is their access. So again, this is probably the scenario. And the thing that we have to do is, if you have to provide access, it has to be timed, it has to be scoped, and it has to be audited, right? So again, the pain points, as you can imagine, is if you're handing out or if you're adding developers to groups using configuration files, that is going to be error prone, right? And there is no centralized auditing framework. Because once you add someone into it, how are you going to say that, hey, you know what, I did this? Sure, there are tickets, but is that enough? And this is where we leverage, again, long-running workflows in Temporal. Essentially what happens is, say I'm a developer, I want to make change to my awesome AI that will hopefully grant me $1 billion. So essentially what I do is, I go to Clutch and I say that, hey, I need to modify this. I need to download maybe the latest model. And Clutch instantiates a long-running workflow. And basically that request goes to the developer's manager for approval, because only they know what is going on and they can take the right decisions. So they can approve or reject. If they approve it, again, there is an activity that is executed for the desired action, and post which, if they're rejected or if it goes through, a notification sent to developers. And the best part about this is we already built like a centralized dashboard so that when auditors come in, we just point them to the dashboard. They can see like, hey, you know what, this is what is done in the last 6 months. And we know who approved what and what actually happened. And we actually time the access. So there is a timer running inside of each long-running workflow. Once their access sort of expires, that's it, we kick them out. And they have to request it again. So that's a very nice workflow. Another thing is, again, schedules. How many of you are using schedules, temporal schedules? Okay, yeah, it's a very underrated feature. So essentially, I'll tell you a scenario. We need to provide visibility to stakeholders, right? This is with respect to your inventory, the cost of inventory, the security vulnerabilities that appear, right? And you need to secure your workloads. But the pain point is, again, that all your data sources are fragmented. There is no centralized view, again, like I mentioned, and security becomes an afterthought. Suddenly you see that you pulled the latest model, but the model has, malware. And next thing you know, your whole application goes for a toss. So what we did with this is we created schedules, right? Temporal schedules are nothing but essentially crons. And the best part about this is I don't have to bother writing another Kubernetes cron, or I don't have to run maybe a cron in a cron tab in a VM. I can just create a temporal schedule. Of course, I can trigger it on demand, but I set a period for it to run. And once it fires, each schedule does something different, basically each workflow. Essentially what they do is they assess, this could be like inventory, cost, security. They query information from different data sources, and they update all this information with Clutch, and we just fire notifications to teams. So if they want to drill down, they can go to Clutch. All of the information is present there. So we're, again, on the daily basis, we are being very vigilant, right? So we're helping developers right size, we're helping them reduce costs, and we're helping them keep their code clean and not use any vulnerable packages, right? Secrets management and rotation. Of course, this is something that everybody faces. Essentially, you have millions of services. All of them use some kind of a credential, maybe for accessing databases, clouds, tokens, everything, right? And obviously, the pain point is that you have to make this compliant, and you have to provide like least privilege, right? You don't want to give a guy privileges to drop your whole database, and one microservice goes rogue and your production is out, right? So with this, we can leverage, again, long-running workflows and signals. Essentially, for a given developer environment, we run one workflow. And there are these services that everybody is running. These workflows are aware of what secrets they're using, because all of that is stored in Clutch. And when it's time, we renew it very seamlessly. We rotate it. And finally, because this rotation takes place, we have to signal ArgoCD now that, hey, you know what, the credentials is rotated. Why don't you go ahead and refresh the app? Because ArgoCD is already tracking it, it just deploys these changes to the intended cluster or clusters. Okay, this is an interesting one. Life cycle of developer environment. So again, if you're a dev team, you know for a fact that you need multiple environments, right, to run your QA staging as well as your dev. And for us, it is more that we have to test these across different clouds, because we have products that can span across different clouds, and we sort of have to make sure they work airtight, right? So again, pain points, as you know, is if you were to do this manually, setting up a new environment takes days or weeks, because you have so many microservices, you have to get their configuration right, and obviously there's a chance that you will blunder simply because you're doing it manually, right? Again, Clutch to the rescue. We written workflows in such that we're adding compensations for rollbacks, and let's just see what that is. So basically, a developer comes in, they want to either launch or destroy an ENV, they go to Clutch, and essentially that launches a new workflow. It runs a series of steps. These are simple activities, of course, there is nothing special in this, but the best part about this is Temporal gives you this notion of compensation. So even if something were to fail, there's always like a rollback or a retry, right? So in order to spin up new resources, we use this open source library called CDK8s. Essentially what you can do is you can programmatically generate your manifests. And of course, because we know what everybody has, the data is persisted in Clutch, we can just spin up these files, sync it with Argo, bam, you deploy it on a cluster or you remove it from there. It's all very seamless, right? This is probably being used by our QA and integration environments, where they bring up something on the fly and they tear it down as soon as they're done with it, right? So yeah, this is the last use case. Personally, I really like this. So whenever you give access to Temporal, dev teams love to abuse it. They will put anything and everything in it. Now, we've seen guys putting credentials. We've seen people just taking like, I don't know, 20 MB payloads and like shoving the workflow with it. There are some limitations with Temporal. Essentially, you can only have about 2 MB of activity payloads, 4 MB of per event history transaction, and overall 50 MB of workflow execution history. Of course, all of these are fine to tune, but the problem is I probably don't think it's recommended. So what Temporal allows us to do is, it allows us to extend and build a codec server, right? So let me just show you what that looks like. This is your typical interaction, right? You have your client worker, which is running some code with the client SDK, and you talk to Temporal service, right? What I can do now is I can actually run a separate codec server, right? Its only job is it gets payloads, writes it to a pluggable storage backend, and that's it. If you want, you give it back. The good thing about this is my pluggable backend can be anything. It could be like object stores, like Nutanix objects or AWS S3, or even, I forgot the GCP one. Or you can even have it like a Postgres database, or it could be your Elasticsearch. It could be anything. That is the best part about it. And now the codec lives inside your code. So essentially, it is a middleware where before it goes to your temporal server, the activity is intercepted by your codec, conversion is done, and basically it encodes and decodes, and it writes it to the codec service. Just talk a little bit more about it, seeing as though we have time. Okay. So if you see this, this is from the Go SDK, by the way. Temporal has, by default, these data converters. And the order is from top to bottom. Data converters are nothing but they convert your objects into bytes and bytes into more bytes, right? So at the end, you can hook in your payload codec. So again, let's talk more about that. So if you see, this is what the payload codec looks like. It only has an encode and decode function. It takes in a list of payloads and it pushes out a list of payloads, right? So the implementation is completely up to you. You can use whatever you want. For us, we personally used ZSTD because it offers like better compression. And this is what it would look like if you were to write your own codec. And the best part about this is you can just call it in your, what? Oh, sorry, yeah. You can just call it in your client. So as you can see, right? When you're invoking, basically you can set this data converter to be the last one so that when the order goes from top to bottom, you see that the bottom is called last and it can interface with your codec server and encode and decode data. So I mentioned here that we can provide payloads, right? So what exactly is a payload? A payload is nothing but two fields, metadata as well as data. So for plain text, it looks something like this. And data could be anything, by the way. You could have like a JSON with like credentials to your master database. It could be anything. So once you convert it though, it would look like this. This is the encoded payload. And if you see, there is a reference called key. So this is being passed to your codec server in order to get the data back, right? So again, when we go back, all the codec server does is the encrypted payload, it gets it, writes it somewhere, returns a key. Right? So that implementation, again, completely up to you. So again, Datadog has done a very good implementation, but unfortunately, it's not production ready. We obviously took ideas from there and we made it we have our own fork where we have it production ready. This is the whole interaction. So in conclusion, I still have time. Key takeaways, yeah. So Temporal, really good. Workflow as code. It's living beside your functions and your business logic. Very good. It helps us integrate seamlessly with external services. We have things like query handlers, signals, and even Nexus. That is something we have to evaluate. It helps us design with idempotency. If you know for a fact that your code will always run the same each time, then there is going to be nothing that is unexpected, right? Okay. Like I mentioned before, it has built-in observability. It has APIs per workflow as well as across namespaces, across namespace. And the best part about Temporal is it is cloud native. I can run it wherever I want, simply because I can containerize it, I can push it everywhere, right? That's a very powerful feature to have. And finally, it really simplifies distributed systems management. I mean, since we already have microservices, I don't have to worry about coupling things together. In fact, I want them to run decoupled so that only services that need to interact with each other do so only through the workflow. And again, here, to check out is Nexus, because I believe it has a lot of capability. So to give some numbers for platforms at scale, we have about maybe 200 microservices. We have about 60 developer environments. More or less, each of these microservices runs in those 60 environments. We have about 350 deployments a day. That comes up to somewhere 10,000-ish a month. And the best part about this is we only leverage about 1,500 workflows per day. Note that all of these are long running, but if you were to see how they complete, essentially, it depends on their use case, right? Because as they breach event history, they do like a continuous new. So in essence, this could be somewhere even like 6,000, 7,000 completed per day. So it could go in whatever per month. So with that, we have 40 seconds. I'll open this up for QA. I thought this would really run through, I'm sorry. So this is my LinkedIn and GitHub. Please do reach out to me. But yeah, any questions? Okay. I feel either session is too good or you guys hated it. So yes, there is one person, yes.
Okay. I'm using up all the time.
Thank you.
12 seconds.
You mentioned that you use the event history for auditing purposes. So I was wondering if you export that after the retention period to Clutch or other called.
Oh, sorry, can you say that again? Event history?
Yeah, so you use the event history for auditing purposes to check what happened.
Oh, no. So we don't use Temporal's event history. We have our own thing stored in Clutch.
Okay, all right.
This is application level stuff.
And another quick question, if you're going to open source the Codex server, because we're going to do something very similar, it would be great not to do that.
Sure, yeah, I'll maybe get back to my internal team and maybe let's see how that pans out. Yeah, sure, definitely will do. Thank you.
Do we have time for more?
All right. Yeah, I mean, do we have time? I don't
Yeah,
think
we can
so.
do one more if anyone has
Just a
anything.
small clarification regarding the codec part, because I spoke with Chad earlier on and I brought this solution.
Mhm.
The thing is, when you implement the codec to get data from data store somewhere back and forth,
Mhm.
you need to be careful because developers will not know that behind the scenes, if your payload becomes 2, 5, 10, 20 megabytes, doesn't matter. Now, during the replay history, when you're rerunning the workflow or whatever you're doing, now you're going to start getting penalized because unknowingly, you don't know that basically as you go on through each activity, you go back and forth to your codec server, you get the data, you send it back. So usually what he was recommending, because they're going to do a blog post about it, because I know Datadog did their own version of codec, so it just goes back and forth automatically.
Yeah.
Just be aware that developers will just use it as they need, as they want, and without knowing that basically you're going to have a penalty on the event as you do the replay of the event. So just it's better to, unless you know what you're doing, it's super fast within 100 milliseconds, sure, go ahead and do it, but make sure the developers will not abuse it because all of a sudden when you replay every activity step you're going to do, you're going to get penalized because you're going to go back and forth
Right.
downloading history. That's the only.
Thank you so much. Yeah, network latency plays a great role there as well. Yeah. So yeah, sure. Thank you so much. Please catch me offline. Thank you so much again.
Okay.